Couple of speakers to start off with. Firstly, John will talk about the discovery protocol. So this is something that has not yet been standardized. So he's going to put up some proposal that will then be discussed by the working group. And then we have a discussion on multi-constrained path selection by Miroslav Živkovic, I believe, roughly. Almost. Apologies, I got that pronunciation wrong. Then we'll have a discussion about the chairs of the working group and discussion about formal requirements. So over to John.
Did they just put that down for me? Because I'm a wanderer. Nice. Shot caller. Okay. So in release 1 of NSI, for those in the room that are new, we wanted to work through all the issues with the connection services protocol that we defined. Okay. So we knew we needed to do dynamic discovery for capabilities of NSAs. We knew we needed to dynamic discovery of topology, but in release 1, we didn't want to put effort into defining those protocols until we understood all the issues and resolved what we could in the connection services protocol. So topology distribution in release 1 for the test deployments. We basically used a centralized model where we deployed basically a master template in GitHub. An NSA would go to GitHub, pull down the master template, and there would be URLs that would tell you where the NML topology documents were, whether it was hosted in GitHub or off the NSA itself. Okay, so this was just a workaround that let us get some aspects of dynamic topology discovery going. But really, we wanted to prove out the connection services protocol, okay? So CS 2.0, that effort came out of the 1.0 learnings and adding additional capabilities that we needed. We also started at the same time working on topology discovery and NSA NSA information discovery, okay? Now, based on our deployment models that you saw for a tree in the chain, these requirements have basically come from that. So your NSA has restricted connectivity. We talked about that. So your signaling plane graph is not fully connected. Your chain deployment requirements are basically get your documents from your peers for your NSA information, but you need all interconnected network topology in order to do your end-to-end pathfinding, okay? Because you've put a physical restriction on your control plane or your signaling plane such that it's congruent with the data plane, you don't need your signaling topology in that case. From a tree deployment, we can separate the elements of your deployment out with different requirements. So your ultimate requester, it's issuing the requests into the network for connections. It really only needs to discover its local aggregator and what its connection services endpoint is, okay? So today, we provision those. You provision it based on the version that's running for that aggregator, and your URA connects to it. If they want, they can discover a topology, the discovery document to dynamically get that, but in the simplest scenario, they don't need any information. Your UPA because it represents the network resources, it's not consuming any data from other NSAs, it's only producing. And what it provides is basically the topology for its network, as well as the networks it manages, the interfaces available off that UPA, okay? The aggregator, the most complex entity in the network, it requires all the NSA discovery documents from the network, as well as the topology of the interdomain connections in order to do your end-to-end pathfinding, all right? So those are the basic requirements for the Discovery Service. Now, I did the chain, so everybody was here for how the chain works and for how the tree works, so I'll just go on. So now what I've done is the proposal here is a combined topology discovery and NSA discovery protocol, okay? Having looked at the requirements in the tree mode, they're basically identical, okay? You need all the NSA documents, discovery documents from all NSAs in the network. You need topology documents for all NSAs in the network. So what I did was I made a generic NSI discovery protocol that is really just a document exchange protocol, all right? Instead of making each of the interfaces specific to that information, all I've done is said, you know what? We want to exchange NSA discovery documents. We want to exchange topology documents. We want to exchange service descriptions between networks so you can find out where the services are end to end. I'm sure in version 3 there's going to be more information we want to exchange. So I thought, what the heck, let's have a go and do a generic peer-to-peer document distribution mechanism. It supports both polling and subscription-based notification. So you can exchange documents by basically doing gets, and I can also do notifications for dynamic updates, so based on filters. So what is a document? A document's a piece of information that needs to be distributed to all participating peers in the Discovery Service. A document is wrapped in metadata within the space to allow for identification and maintenance. Okay, so basically, you're going to publish a document, it gets wrapped in an envelope, and it gets distributed throughout all the aggregator NSAs within the network. Anybody can participate in the protocol, but really it's your core aggregators that want to get this information and in order to do their intelligent function. The key here is the original document contents and associated metadata are propagated untouched through the document space, okay? So I don't want to have to understand what a document is. I don't want to look at the contents, and I don't really care about validating that document. That's up to whoever's going to use it. I need to be able to propagate it, and if new ones are added, I need to be able to propagate those without having to understand them, okay? So that's one of the keys of this solution. Okay, so the document itself, so the metadata associated with the document, so basically we have the NSA that generated it, so your UPAs that are producing these documents or your aggregators would identify the document as coming from itself. It identifies the type of document. Now the type of document, what we're doing is, because in NSI we're identifying our interfaces and our information types using the media types, we'll reuse those for identifying a document. So in this case we have two versions of topology. We've got our NML topology version 1, and we have our NML topology version 2. So those would be two examples of document types that get propagated through. And then an identifier for that document. Now, because of the way we've been defining our topologies, a topology has an identifier representing that network. So if you have two versions of the same topology, just in different representations, then they're going to have the same identifier. So that identifier can be, for example, your network ID, and I've loosened the restriction. The ID does not have to be globally unique. It only has to be unique in the context of the NSA and type. Okay, so I can publish the same topology document for the same network using two different versions of it and I can use the same ID, and we can uniquely identify that. Okay, the version field is basically the timestamp that that document was generated at, and that version is used in the propagation to determine if you've already seen that document. Okay, so if you have the same version ID and you happen to see that document come in again through a notification and it still has that version, then you know it's a duplicate. Expires, that metadata field is used to identify when the document becomes invalid. Okay, so if I publish a document, and the reason we put it in there is, for example, if I publish a document about a network and it gets propagated through, and then I change my network name, theoretically that other document is going to already exist. So if I don't remove it and just publish my new one, the other one's going to dangle. So we put an expiry on the documents that allows them to naturally expire after time. And then basically if you want to update the expires time on the document, you just generate your document with a new version, and the expire time can be updated. Okay, even though the contents are the same, you're generating a different set of metadata, so it requires a different version number. Now, the requirements were that the documents could be individually signed so that they could be validated by the end user of the document. So what I've done here is I proposed we'd have a separate signature field and then the document contents, okay? And it allows you to sign the contents, put the signature in this field here, so that when somebody reads the document, for example, a pathfinder wants to use that document, it can use that signature to validate it, okay? We've been talking about different PKI solutions for that. I've left it external for now. I put the field there for demo purposes. I can use XML SIG, which was what I was looking at sticking in there just to sign the current XML documents we have. However, nothing saying the content of the document needs to be XML. So there's other solutions that can be used. I view it as more of a deployment option, but I know people in the group have commented that we need to come to an agreeable solution before we can validate the protocol, and I have no problem with that. So that's the content of what I call the document metadata that gets propagated through the protocol. Subscriptions, so when I subscribe for notifications from an NSA, I get back an identifier that uniquely identifies the subscription, an href to the resource. Basically, if you haven't picked up, I did a REST-based solution, so everything's modeled as a resource. The version of the subscription, the requester ID, so who requested the subscription, that allows me to filter requests. The callback, so what we've done, since we have the interfaces, I've defined interfaces to do polling, and you can use last modified time to get back only the documents that have changed. We decided to make the notification solution basically a physically separate HTTP callback. Okay, so you send in a subscription request specifying the endpoint that you'd like the notification sent to, and then we do a post to that callback address. So that would be the callback that the person wants their notifications of document change sent to. And then an optional filter that lets you filter on basically all documents, all events on all documents. It lets you filter down on only certain events on certain documents. It's got some granularity there. Here's the abstract APIs. So from an operations perspective, you can do a get on documents with filters for NSA type ID and the last discovered time. What we've done is inside your aggregators and your UPAs, the last discovered time is the time at which you learned of that document, not the time the document was originally generated. Okay, so it lets an NSA, when it comes up, it discovers a bunch of documents that have already existed in the network. A client can ask for all new documents, and he'll give you back the time that that NSA discovered them. So you're in the context of the NSA as opposed to the global creation time. An operation to get local documents. So in the case of chain, if you're in chain mode, all you want to do is learn about the local documents from that NSA. You don't want to learn about everything, so you can do a retrieval on local. Get a specific document, add a document, update a document. The add and the updates are really for local use or access controlled use. So if you have scripts or something that are generating them locally, you can use those operations to publish your documents. Then you have the subscriptions, so add a subscription, edit, delete, get all your subscriptions, get a specific subscription, and then a catch-all that lets you basically pull back everything you want, both documents and subscriptions. Okay, so as I said, there's two models going to be used here. So there's the standard request response model. So I send a request into the provider NSA to get all documents, and it is going to, in the response, send me back a documents element that contains the list of documents that matched my search criteria, okay? And those would be basically whatever in the document space of that provider. So if that's a UPA, that would be only the local documents. If that's an aggregator, the search would be in the context of all the documents that it has currently discovered and has in its document space. Oh, I didn't realize this was animated, sorry. Okay, so basically we're going to use, as part of the protocol, a basic HTTP binding. So you're going to do HTTP gets, in this case on the resource called documents. It's going to send back a 200 OK with the results. And the socket blocks until the results are returned, so it's a synchronous operation. So that meets our firewall requirements. Through use of the last modified time in the HTTP header, you can get back only the documents that are new from the last time you did your poll, so we reduce the polling traffic. And that covers off the basic request response. Now for the subscriptions, it's going to be asynchronous, so when you do an add subscription with your filter, you also provide your callback. The provider stores that, and anytime a document event within the document space meets that subscription filter, you generate a notification and you send it to the callback endpoint that the requester NSA has provided. Okay, so if that requester NSA happens to be an aggregator and it's connected to a local UPA or to another aggregator, when the minute a document event happens in that aggregator or UPA that matches that filter, it'll get updated. The other thing is that on a subscription, the initial filter will basically generate notifications for everything that matches it in that space. All right, so I don't have to do a poll. All I do is do a subscription, an add subscription, and then I'll get back notifications for everything that matches it, so I instantly get updated. All right, so basically this is an example of a simple flooding algorithm that allows the documents to be sent through the space. So on the right-hand side, we have UPA-A, who basically has a local update of a document. Let's say they run a script that generates a new version of topology. So it's the local UPA gets that, it updates its local document space, and then it'll notify anybody that's registered for notifications on that document. So in this case, I have a sparsely connected set of NSAs. It's got UPA-A has an aggregator B that has registered for notifications. So the 1.2 version gets updated. The notification is sent out to aggregator B, who then propagates it. So he's got two adjacent aggregators, C and D. They've registered for notifications on him for any document change. So he propagates those documents out to those two aggregators. Likewise, on the bottom, C will propagate it onto D. Now, aggregator D gets the update 1.2 from two directions. It's already seen it from B. It gets the update from C. It goes to update the document and finds out that it's a duplicate of the one it already has because of the version. So it doesn't generate a notification for that one, but it will generate a notification for the original one that was received on B, which gets sent to E. E updates its local document space. And basically, it's an end node. It has nobody registered to it. The one above is its UPA, so it's registered against it, but the UPA doesn't need an update on documents because it doesn't care. So basically, the document update finishes there. Any questions on that? Nope, okay. So here's the resource model. So we have a collection, which is basically a hold all to hold subscriptions and documents. So if I do a get on the root, I can get everything back. I've got a subscriptions resource, which lets me get subscriptions, a list of subscriptions, and to post, effectively create new ones using the post operation. I've got a subscription resource, so I can do a get on the subscription to get back that individual subscription. I can do a put to edit the subscription, so if I want to change my filter, I can do that. And then I've got the delete that will remove the subscription. Documents, I've got a get on the documents resource. It'll get any document meeting the filter criteria. And I've got a post on documents that lets me create a new document in the space. And then I have a document resource, which a get, a put, or delete. So a get on that document will give it back to me. A put will allow me to edit it, update it to a new version, whatever. And then the delete allows me to, actually, that's a mistake. There is no delete on document. And then a local get, the local resource returns the context of documents for the local NSA. Now for the document, I had discussed with a few people about doing a delete on the document to remove it from the space. So this is a version earlier from the discussion. And what we actually agreed to is instead of adding a delete operation on the document and require a delete notification be sent out, that a delete would actually be an update, so a put on the document with a changed expires time. So basically you do a put, you edit your expires time to either now or relatively soon in the future. That gets propagated across, everybody gets a new updated expires time, and then those documents can be cleaned up based on the policies you have for expires time. So if you want to leave them around for an hour afterwards, so any UPAs or, any other aggregators can get access to those documents and see the expires time, they can. If not, then you can remove that document as soon as the time occurs. So that saved us having to define another event in the model, which I should have put in the slide pack, but I didn't. Here's the URI layout for the different resources. So for the collection that gets everything, it's on root. Then I've got a subscriptions URI. I've got the subscription ID under subscriptions to get the single subscription object. Documents is /documents. And then you've got a few derivatives from there. You've got documents /NSA to get all documents associated with a specific NSA. You've got NSA and type to get all documents of a specific type. And then obviously you can go and get a specific document by specifying the NSA type, NSA ID type and ID. And then your local URL is /local. All right. There are a lot of, anytime you say flooding protocol, people have a major panic that it's going to consume huge amounts of resources. So what I did was I took the existing size of the document that we've defined, and I expanded them out a little bit to cover basically the, from an NML perspective, we did a 1,000 port network where we basically had 30% interdomain ports, 70% end ports, and I used the port group summarization mechanism so that you can specify thousands of labels on those ports. And basically we came up with NML topology file with 1,000 ports is about 1.5 meg per UPA. The discovery document is about 5K, and if you only, and the one good thing about NSI is if you want to just do intradomain routing, you don't require your end client ports because those STPs are within the network and you're really just routing between your networks. If you wanted to do internal routing as well, which you're free to do by providing more information, then you'll need those endpoints. But basically, you would drop your topology down to about 300 ports for an example network, and which is 450K. Now, given I don't need to look into the document for this protocol, there's no reason that I require it because all my routing information, identity information is in the metadata. I can compress those documents down to the column on the right-hand side, so about 2K, 85K, and 26K respectively. So if we then look at a global network size, an aggregator that exists in a network where there's 10,000 networks would roughly have a compressed size of 850 megabytes of data. Okay, so that would be what the document sizes would be total. And obviously the numbers go down as the network decreases in size. Now, based on those numbers, if we looked at reducing from 1,000 ports down to 300 ports, we get the table on the bottom, and that's down to 273 megs for 10,000 networks. Now, based on the protocol, the worst case scenario is you'll get a document propagated from every neighbor before, it could be the exact same document from every single neighbor. You never propagate to the neighbor you got it from, so basically you won't be causing broadcast storms. Once I've seen it, I only propagate one version of it, so that's good. But if we take those numbers and we assume, and at this point in time, based on what we've had with our documents, the discovery documents, or the NSA discovery documents, are very static. They don't contain anything that's too dynamic in our situation. And our topology, because it's high-level service topology, it's not impacted by links going up and down. So those don't get advertised, so it's very static from a pathfinding perspective. So if you wanted to do something safe and update once, send out an update once a day, then you're looking at about 80 kilobits background traffic, as long as it doesn't all show up at once. So it's not unduly strenuous on the network. 850 megs in memory isn't huge these days. 14.6 gigs is. So, and depending on your Pathfinder, if your Pathfinder is doing pathfinding on 10,000 networks, it's going to need to be able to optimally build an in-memory graph. Yes, sir.
And this is reasonably static, right?
It's reasonably static, so it's not churning. So the protocol, I'm not worried about the protocol itself. We are using XML. Like, have a look at the compression ratio. I went from 1.5 megs down to 85 kilobytes. I mean, it was a huge compression because it's all repetitive data. They're long strings in the NML, XML representation. When you get it into memory, that 850 megs the 14.6 gigabytes isn't 14.6 gigabytes because you're reducing it from a very verbose XML representation down to an internal memory structure. So I don't think it's that bad. And then if you want to use more advanced techniques like databases that allow you to do graph traversal, you could do things like that, and it doesn't even have to be in memory. So I think that was my last one. Any questions?
Is there any provision for incremental documents?
Okay, good question. So we had discussed doing incremental documents in Release 2, and the answer was, given how static they are and how infrequent they're changing, that we wouldn't put the effort into doing it. I think going forward, we're going to have to look at it, especially if we want to put more dynamic information in there. And at that point, we just need to look at what an incremental update looks like. And I can propagate anything, I think it's important. We should probably discuss in more detail what an incremental update would look like. But yeah, no, right now there isn't, no.
I hear what you're saying on that. The expiration characteristic is what makes me think that I might be sending the same document essentially over and over again with different expiry dates.
Yes.
And so sending an incremental update that says no change, new expiry date would be much more efficient than here's the thing, compare it and see if it's exactly the same as the previous one, in which case you don't need to do it, or even more destructively tearing down your internal data structure
Yeah.
in memory and recreating it from exactly the same information over again. And the reason you need to keep your expiry date in close is to give you flexibility, because if you don't know when your next change is going to be, you have to, like DNS, put on a sufficiently low lifetime that it's going to end up being sending every few hours or few days.
Yeah, yeah. So yeah, I agree with that. The one problem, and it really came down to how are we going to sign the documents and maintain signatures. So right now, in order to simplify things, we said, okay, if we just did a signature on the full document, you put that in, you propagate it. Okay, somebody can verify that document using the signature. Now I'm going to send an update. I can't, as an aggregator, update somebody else's document and re-sign it because he's the one that originally signed it. So now I need the original copy that somebody can validate, and then incremental updates that they can also validate signatures on. So we said, okay, that's going to become rather complex from a signing perspective, so we might as well just do the full document as a cop-out, really. But I understand what you're saying, and I think we need to look at it more closely.
There are two goals, they're both good, but they interact in opposite
Directions, yeah, yeah. We really need to work out the security side of it.
Sorry, so my question is how does the Genie community actually address this? Do you guys have a way of addressing topology changes, incremental changes? I'll be interested to find out.
Repeat. So at this point, what we are doing, just like what you are doing for your OGF demos, so basically all the topology files are pulled out of individual aggregates and put into a single place. So we pull the topologies using the Genie API by list resources. We just do that periodically. And yeah. So you have a centralized? Yes, we do. Yes.
Okay, so keep the microphone. Keep the microphone. I got questions. No, give it back to him, Tamiro. Okay, so you guys could be good user input here. So in our situation, we were saying that discovery documents, topology documents are considered private information and should only be propagated to trusted people in the relationship. Okay, so aggregator NSAs are trusted with UPAs, so they're allowed to get access to the information in order to do their tasks. In your situation, it sounds like all your entities are going to a centralized spot to get the data. What security are you using in that situation?
So there are two things here. First is what kind of information you are advertised. And at this point, for stitching, all we care about are those endpoints on the aggregates. So we're not advertising the full topology. This is one. And two is who can get those. At this point, there's no policy for Genie to actually limit who can retrieve the advertisement from aggregates. So for stitching service, we are just using the regular API to pull information out of aggregates. So whatever is available, we're going to put out.
Okay, so you don't have requirements to restrict access to the data?
No, not yet.
Okay.
In actual Genie, we have this broker entity that every AM can delegate its resource and the abstract view to the broker. So the trust relationships between the broker and the aggregates. So basically, you can delegate different views of your domains to different brokers.
Okay.
That's the one thing. Two, we do use compressed. Yeah.
Okay. Yes. Back,
Thank you. Yeah,
back.
I was wondering about the semantics of your version numbers, because I see that you're using something like 1.2.
Actually, I just put that in because I couldn't stick a date string in there.
Okay, so it's basically something like a linear ordering. Okay.
Yeah, I'm outside the thing. Yeah, no, so what we're doing in this proposal would be you sign the version with basically the date it was generated on. And since your document, a specific document is only generated by one entity, that's safe because obviously he can't generate two documents simultaneously in the same second of the same version. So, yeah, and once as that version goes through, the behavior is it's a date. So the version that's later will have a later date field.
Okay, thank you.
Anything else? Okay, I'm done.
Okay. Normally, we do, in these standards meetings, we have some very vociferous participants who don't happen to be present, actually. In fact, there's two of them I can think of at the moment. And
I didn't get yelled at once or called incompetent, which is
yeah.
a change.
But I'm going to stir things up by asking a question that was posted on the mailing list, which was around this is quite a complex mechanism for exchanging documents that you're proposing. Do we need to reinvent this? Are we reinventing the wheel here? Is there something else that we can use that might do this job for us? Perhaps either John or open it up to Chin.
So my opinion is if there is a alternative method that they should, formally write it up and propose it. So instead of saying, is there an easier way of doing something that we're already proposing? If someone has a better idea, they should definitely bring it up and then have us look at it, I suppose. If we're going to change the way we do something, we probably should have an alternative before we change it.
So it really
Right.
comes down to what are the requirements, okay? So I built this or proposed this based on the fact that we have to follow the same level of trust, the same topology that we have in the connection services, right? Which is you're setting up a finite set of peers, you're managing the TLS, so that if I need to discover somebody, I have to follow that same signaling plane topology. If, for example, we say, no security is required, topology and discovery documents can be wide open, then that changes what needs the requirements, and something can be a bit different. Like if I can go out to each NSA and now directly discover their information, then really what I need is from my peers, I need to discover which peers they're connected to and their discovery interface, so I can then go off and pull them for their topology. So it changes. Or, for example, the lookup service that we've talked about before, where you can distribute a number of centralized lookup services that you can then go and pull from. That's a totally valid topology solution as well.
Right.
But those are different sets of requirements that drive those. And if we want to change the requirement set, then yeah, the solution can change, right?
Sure. Okay, so I think the answer is if anybody can think of a better method, you know of a better method, do let us know. There is a NSI mailing list. If you want to subscribe, just send me an email or any of the co-chairs an email. We can put you on the mailing list for NSI, and you can see the discussions there, and then you feel free to post any proposals. Okay, so I think we're out of time now, so thanks, John, for that helpful presentation. Very good proposal. So next, Miroslav will talk about his exact topic is, let me see, so the multi-constrained path selection. So.
What's that? You have HDMI? You don't have a VGA? Does anybody have a VGA to HDMI connector? Anybody? Anybody? No? Do you have a memory stick?
I don't.
Just need to transfer his presentation. Yeah.
Do you want to put the microphone on?
Or can you email it to me? Email it to me. dongle's right here, yeah. If you email it to me, then we can pull it up here. And then-
Hi, everyone. While this is going on, I just want to make an announcement as well. I've been listed as one of the co-chairs, and I've been the co-chair since the NSI group started. And I think it's fortunate or unfortunate at the Genie group, but I'm going to be stepping down as the NSI co-chair, and mostly because I've got too many time commitments at work that I'm not able to spend the time it takes that it needs to be. So my co-chairs probably need another actively working person. So from my perspective, I think the process that we agreed upon is I'm going to step down, I'm going to nominate someone who I think will be a good co-chair, but we'll keep it open and other nominations will be solicited. So if anybody is interested, they're most welcome to jump to that plate. I want to nominate Chin because I think he has been doing a great job in driving the protocol forward, and he will be a good force in making this happen. But I'll have Guy drive the nomination process since I'm no longer a co-chair. So by the way, it has been great working in this group, and I'm glad to see we are at the 2.0 protocol. But I think there's still challenges to get it fully deployed, so that will still be something that the group needs to work on. So thank you everyone for all your support and help so far.
I'd just like to say just a few words about Inder. Inder's been an absolutely invaluable co-chair for the NSI working group. He's really put a tremendous effort into making everybody aware and bringing everybody together to make NSI work. So really, as an evangelist for NSI, has done a fantastic job, and really bringing together all the different groups and helping glue that together. So right from day one, early on, when we took on Inder, he was still in industry, and he's since moved over to ESNet. And it's been a really positive few years, and we appreciate that you've got other priorities and you're moving on to other work. But I'd like to thank everybody. If you could thank Inder for his contribution. As Inder said, Chin has been nominated to take over. So Chin is also in ESNet. What we'd like to do is try and preserve the balance. We have three co-chairs, one from Europe, one from Japan, and one from the US. And if possible, we'd like to keep that balance going. It's not a fixed requirement, not necessarily the way it has to be. But I would certainly be very pleased to see Chin come on to the working group as a co-chair. But if you've got anybody you think would make a good co-chair, do feel free to send the nominations to the mailing list, and we will consider those. So that nomination period will be open for another week. And if we don't hear anything, Chin will take on the role. So do let us know if you've got any other nominations. Okay, so how are we going there?
We are on time.
Great.
On target. Okay.
Right.
1, 2, 1, 2.
Over to you, Miroslav.
Okay. Thank you, and sorry for this. Well, let me introduce a little bit myself. I'm Miroslav Živković. I have recently joined the University of Amsterdam, and that means that I'm still a bachelor to NSI, NML, and so on. My background is not exactly networking. I come more from, let's say, performance engineering, applied math, optimization kind of background. And I have been involved in a project that deals with multi-domain open flow topology exchanges. As a consequence of that, I am also part of NSI NML. And the work that I'm going to present today has been done in collaboration with my colleagues from Surf-Sahara and University of Amsterdam. So let me just say that the work that I'm going to present today is very preliminary, very basic. And as the title says, I'm going to talk about multi-constraint path selection. I have a personal goal not to explain the algorithms, methodologies, analysis of the algorithms, and so on. I will just give a hint of some very basic elements of multi-constraint optimization, if you want. And then I will translate that into the NSI framework and try at the end to deduce some requirements that have not yet been scoped within the group. Okay, so multi-constraint path selection. What is the problem here? First, we start with a model of the network. It is a network topology, and in my view, it is nothing else than the graph. You have been probably exposed to the graph theory a lot. For us, it is important to say that the nodes represented in the graph are actually the domains in the NSI, and the links or edges, as we have them, are part of SDP, or demarcation points in the term of NSI. Each link could have a number of parameters that describe it. A number, if you want, of quality of service parameters, like delay, like cost, like energy usage, like technology, and so on. In order to capture this in one line, I use the link weight vector. So I use a vector to represent the link, inter-domain link between the two domains, and the different QoS parameters are different elements in this vector. These vectors should satisfy a certain requirements that are presented by the user that wants to set a path from source to sink, or from the source node to a destination node T. And taking all this into account, so the description of the path or using the vector representation of the links, the requirements that are imposed by the end user with respect to cost, energy usage, delay, whatever, the goal and the problem of multi-constraint path selection is to find a path from the source domain or source node to the destination domain or the destination node that would satisfy this equality represented at the bottom of the screen. So in this, what does it say? Basically, I select the path from S to T, for instance, S, V1, V3, V5, and T. And then I look for each of those path elements whether all the constraints for quality of service have been fulfilled. If yes, that's my path. Okay, let's go one step further. The assumptions that have been under this problem is, first of all, that I have a complete view of the topology, of the network topology. Why is that important? Because in the current work done at NSI, basically the first solution that is found, that's it. We are happy and we don't think about what is going in the future. This solution may be not the optimal one, maybe not the preferred one, and so on. So that's one of the problems. Second, as I have already said, different parameters could be used to describe a link. These parameters could be additive in nature, like the cost, or those parameters could be something like minimum, maximum value. how do I approach this? Well, I could basically do an exhaustive search of the graph and see, yeah, what is the best solution? Does it satisfy my constraints and so on? But of course, we are very well aware that this is not the good approach. So, in way to address this, instead of dealing with multiple dimensions of the vector, I will just introduce something called the path length. And then I'm going to search through the paths using this path length notion. So here are just two examples. How could I define a path length? I could define it as a linear function or nonlinear. I will not bother you with this. Just what is important is to see that we still have the elements of the vector describing the link in those equations. Once I have defined the path length, I have to do a search. And so what do we have here? This is just important. If I explain this well, I think the rest is not the problem. And this is the last involved slide here. So every path in this graph is represented by a dot. Every link in a path has only two elements that describe it, so two weights. That's why we have a two-dimensional graph. So for weight 1, we have certain values for the selected path, and for weight 2, we have certain values for the same path. And all of these give us the dots. Okay, now the constraints. I want that costs are limited by $10. I want that energy usage is that and that, or less than that. So the constraints are indicated by L1 and L2 values on the axis. So the QoS for the certain path should be less than or equal L1, and QoS parameter 2 for the same path should be less than or equal to L2. And now I have to search the path using the methodology. So what am I going to do? As I have said, we have the linear equation of the path length. This is just given that. In our graph, that's nothing else than the straight lines that are represented on the graph. And all paths of equal length are to be found on one line. Now, we see that there is a circled path here. What is that? That is the path that has a certain length that is indicated by the line that it finds itself on. But we see that this path is outside of our requirements, so it's not considered. And actually, if we have this situation, these requirements, and so on, the selection will be the dot that is within the square, and that is our path to be selected. That path has the quality of service requirements that are satisfied, and the values are easy to be read. Yet another thing here is important. Maybe some of you know that the sum of values should be less than or equal, or actually should be equal to 1. Why is that? When I'm going to search the fastest through my domain, the fastest search is going to be done if we look a line with a circled point. That line actually has a part that is within the constraint region and a part that is outside. My goal is to reduce the part that is outside of the region that interests me. And the fastest would be if I simply connect this point with this point and specify the path length line for it. Then the search would be the fastest one, and at the end that reflects to that famous requirement, if some of you know, that the sum of the parameters equals 1. Okay, this is when I define the path as nonlinear, this is what we get. It's not important. What is important is to remember, if I use a nonlinear path length, then in multiple dimensions, the subsections, the links that I select for the shortest or the optimal path are not necessarily the shortest path themselves. So I have 2 points. I have source and sink, and I have a number of links between them. If we have nonlinear path length, that means that the links are not necessarily the optimal ones between the 2 domains that are on the path. Okay. Basically, this has not been applied so far in that very much within the NSI. And this is something that we probably intend to do. So how are we going to approach that is also going to affect the topology descriptions that we are going to use. It is also going to affect the path computation elements that we use. It is also going to affect the scalability of solution that we have. The problem that we have within NSI is that we do not do optimization within a domain. We do the optimization using the links that are deployed between 2 domains. So clearly, this is not, in general, an optimal solution. And for the NSI, very important thing is, what if we use, next to these QoS relating parameters, next to cost, energy, latency, delay, and so on, what if we take into account the technology incompatibilities and the adaptation capabilities of our domains? So what do I mean by these 2? This is, first of all, we could have the rate incompatibilities. Well, we could have a link of a higher rate that goes to a certain domain, and then and on the other side of the domain, it leaves like the link of a lower rate. So apparently, the domain would have to do the adaptation or the data rate conversion. So maybe that's important for us within the NSI, maybe it's not. Then we could have the wavelength incompatibilities. And then we could have the architecture incompatibilities if you want. So within certain domain, different layer technologies could be deployed. And within that same domain, we could have the adaptation between the different technologies. Now, the solution that we have for the path selection in NSI does not take into account whether a certain domain is able to do the adaptation between different technologies. So it goes, okay, I take this technology, and the path I set from A to B has to use this technology all the way through. But what if that is not the case? What if the domains in between are able to do some technology adaptations? That is the questions. And what happens after that is, if we understand all the relevant aspects that are important to NRENs and to the clients that we have in mind, we will have to be able to describe this in, for instance, topology documents. And once we have those enriched topology documents, we will have only then be able to perform the multi-constraint path selection. So the question actually to NSI is, what parameters should we consider in the future topology discussions? And of course, I think it would be much easier then for us to resolve these multi-constraint path selection problems. And with this, I hope I will get some questions.
Great, thanks for that, Miroslav. So any questions for Miroslav? Yes.
Thank you. I was wondering if you've got any example of use case for non-linear path costs. Yeah. Because I can understand that linear examples are simple to imagine, like latency, stuff like that. But I'm struggling to imagine something which would have some other characteristic.
Mm-hmm. Okay. Just let me go on. Hopefully, this works. Okay. What is important here? I have a number of links in my network, okay? For each link, I have different quality of service parameters. For instance, 5 or 2, let's say 2, that describe each link, okay? So what can I do? Now I can make a matrix, 3-dimensional matrix, where I would have the links, parameter 1, parameter 2, and then search through all possibilities, do the exhaustive search, okay? That would be, yeah, that's not preferred. Huh? It doesn't scale well, and so on. So what do? Instead of that I have to deal with 2 parameters, or 5, or 10, I will just use one number. And that's defined by this length of the path. So how do I get that number? I take all those parameters, QoS parameters, I make a function of them, and that function could be linear or nonlinear. So it's purely, let's say purely, my choice. Why do I do that? Then the search becomes, I just do the search with length, with L here. Okay, good. Now here, this happens a little bit to be slow, because if I have a linear function, I move with the increase of the path length. I could find the optimal speed for the increase of the path length, but by doing nonlinear function, let's say this one, I do the search of my space much faster. If I have the linear function, it would join this point with this one, with the line, okay? You agree? And I would just be able to search on that line. But if I do this, I much faster cover this region here with the constraints. So that would be one reason to introduce nonlinear functions. And basically, technically speaking, there is not much difference, because if you want that, I just introduce a new matrix into the problem, and then I do search in that matrix space. That's it. But this would be doing a little bit faster than the linear function. The search in the space.
Some parameters in optical networking, like a PMD, phase modulation and dispersion, those are nonlinear typically. They are not just added in one order along the distance. They could be like a square or cube or even more crazy functions. So those are nonlinear. Yeah.
Okay, just one thing. With respect to the parameters, you could have the additive parameters, cost, delay, and so on, but you could have, if you want probabilities that would multiply with each other, that could be reduced to the parameters that could be added if you use the log function. And then the rest is min-max function that is also interesting, but that is, if you want, nonlinear function on the parameters itself.
All right.
Could you tell a little bit about the algorithmic complexity of this problem? And also, in a practical area, you have very, from my point of view, very rigorous restriction which is a complete view of the interdomain topology, because convergence is a very important point for such sort of algorithm.
That is true. Depending on the algorithm selected, there are really, well, basically we would have to go then algorithm by algorithm, but some of them are NP-hard problems. Some of them are not. And if the problem is NP-hard, then you resolve it by using the heuristics that would allow you to do your math, if you want, in real life. Okay. No, I could say, okay, in my heuristics, I will just assume, for instance, I would just say that I would not exhaustively search the whole space, but I just say I would focus on a certain area within that space. That is one heuristic. Second heuristics would be, okay, I would not analyze all the links, but I would, instead of two links that are consecutive, I would analyze one link that represents those two links. In that way, I reduce my complexity of my problem, and that allows me to come with a solution that may be good, that is, again, part of analysis, as the full-blown solution, but heuristics may give me a solution that is good enough for me, simpler and faster to calculate. So that's what I mean by heuristics.
Okay, so let's just a couple of minutes for some more questions, and then we'll move on to the next topic.
Two comments. So to my knowledge, so any constrained shortest path problem is NP-hard. So I guess you have to deal with heuristics to some extent.
Okay.
Two, in practical, you probably don't need to have a shortest path every time, as long as you satisfy your constraints, right? So
that's true.
So
just to react upon that, I'm sorry for this. Once I have the path length introduced, then I could do, for instance, the Dijkstra algorithm on the shortest path length, which is something that is not that much NP-hard, but I can explain that offline if preferred. So most of them, yes, they are NP-hard, but there are some that are not, and there are some trade-offs there.
okay, yeah.
Well, I can explain
I think
that
it's proved that any path problem with more than one constraint is NP-hard, which means if you have a shortest path with one more constraint, unless your constraint is a bandwidth. I mean, bandwidth is, it's as long as it's additive. Yeah.
Okay, I'll take it.
Okay, I think with that, perhaps we can wrap up that session. Thanks, Miroslav, for those insights. So our next topic and final topic for today is the question of requirements for NSI. So this is more a topic for an open discussion rather than a presentation. So the question's been raised, how can we formalize and state in a more formal way the requirements for NSI? So just to explain the history of the NSI connection service version 2. So we went through a couple of iterations. There was an NSI version 1, and that was found to be functionally not entirely complete, based on some work that was done largely within Glyph, the Glyph interoperability testing, and then discussions with the providers, we decided it wasn't a fully functioning set of functionality within NSI version 1. So we expanded that, we gathered requirements for NSI version 2, and that has now been put together into the NSI version 2 connection service requirement. And that's available to download. So if you go to the OGF documents and look at the documents available for comment, that's available for comment, as Chin mentioned in his presentation. And that's available until the 15th of April. So if anybody has an interest in that document, do take a look, do send in your comments, because we're very interested to know what the community thinks. But what we're finding as we now start to write, there was a whole lot of stuff that was kind of put on one side described as policy. So some of the behavioral aspects of implementation, and a lot of that is now being picked up by John. So on Friday, that we've got several hours of implementation meetings, and do go to those, and you'll talk about some of the implementation-related issues. But what we'd like to do is capture the requirements that we discovered. Those requirements were captured in various working documents that the group produced. There were various spreadsheets that we went through in our working meetings, and additional requirements were also captured by John, and if you're paying close attention to his presentation on the Discovery Services collection of requirements, they're captured at the beginning of that presentation, and you'll see that also in that document. We would like to very much formalize in some way, capture those requirements in a document, perhaps an informational document, so that everybody can see the logic of the requirements that were brought together to develop the connection service version 2. So we identify that is what we'd like to do. The question is how we can bring those requirements together, how we can document them, and who's available to help with that work.
referencing topologies of another entity. So for instance, like, how do you prevent someone from actually putting in misinformation?
So when do the topology collecting, we don't do push, we do pull. So we pull topology from aggregates. So when we do this pull, and there is a associated authentication process, credential stuff to make sure we are pulling from the right place.
So I guess
the other
the other one that was brought up was, what's the scalability? Are you guys looking at like 100,000 networks, or I mean, what kind of scale are you guys looking at?
We don't have that scale. In ExoGenie, we only have a few dozen of aggregate managers. A few dozens. Okay. Dozens, yeah, not thousands, you know.
At this point, I think the SS server has less than 20 aggregates. So I'm sure we can scale probably to 100, but I'm not sure if we can do more than that.
Okay, so it doesn't sound like 100,000 is something that you would consider. I mean, so my personal point of view, 100,000 seems to be excessive, and I'm not sure. Well, I just wanted to figure out whether you share. No, this was something that someone pulled out and said, what if we had 100,000 networks? And so my question was, where would you get 100,000 networks? But that was what was brought out. So we wanted to see if it was realistic. So ESNet, when we used to be a tier 1 network, we paired with probably several hundred other networks, right? So we're not even talking in the thousands of distinct neighbors. But that number was just brought out, and we're wondering whether there's some validity to that. And I guess what was the third issue, John?
So we had the security, so the openness of data for discovery topology. Layer 2 and below was the comment. So
Right.
For guaranteed, basically for guaranteed bandwidth applications, anything that's non-guaranteed,
Okay.
use layer 3. And then scalability is basically how big. So they 30.
Okay, so Guy, let me see if I can capture the discussions here that we had, right? So for the Genie community, there is a difference between resource discovery and resource reservation. You guys look at it as if you have different security models for it. Is that correct? I mean, with information discovery, it's more open, but with reservation, you guys have more. It's a tighter control. Is that correct? So okay. In terms of scalability, you guys are talking about dozens, maybe potentially several hundreds, not in the tens of thousands. Okay.
So we always associate the scalability with granularity. There's two pair of consideration, right? So the finer granularity you want, I mean, the less scalability you can achieve. So you have to. That's why we have the different views of the topology. So if you want to get finer view of your topology, apparently your scalability would suffer. So yeah.
How many ports do you define for topology?
Well, right now in implementation, we abstract a domain as one big switch with border interfaces. That's currently what we advertise to other Genie entities. So. It's not quite large. So Internet 2 network probably is the biggest. It's the one with most interface. Yeah. No, we are not even have several hundred right now, because we only have about 20 racks. Let's say less than 20 racks. So most of them are around the ION. So right now we're dealing with, as I said, a few dozens of, yeah.
Okay. So I think we're rapidly running out of time. I just want to say, are there any more questions, discussion? Yes, please.
So using this opportunity, I'd like to ask Genie people's view of advanced reservation and the reservation modification. So NSI supports advanced reservation, and also NSI supports modification of existing reservation, even if it is during the activation period.
Right now, Genie does not do advanced reservation. So the reason, but we do have a notional reservation, which is according to Genie API, that is allocate. So Genie has an allocate and the provision calls, which is roughly the same as your two-phase commit process. So to do reservation, we just make sure you got a coordination of resources across multiple aggregates, but we do not do advanced reservation.
So in Axel Genie, so in request, you can specify the reservation term in future. So in that sense, we do support advanced reservation. But the advanced reservation policy itself, there are two aspects. So one is in the reservation level, in the slice level, we do support that. But the capability to actually accomplish advanced reservation depend on each aggregate. If the aggregate doesn't support advanced reservation, you can the only thing you can do is to defer the reservation to the future. So there are two aspects. So in mechanism we support, but in policy level it's not that. That's one thing. Two, reservation modification. Right now we support reservation term extension. Basically, if you initially schedule ask for a reservation for 1 day, later on, at the end of the day, you want to extend it, we can extend it. It's very easy for we provide the interface to do that. The second modification is a resource modification. Let's say initially I reserve 10 VMs, and in the middle of your experiment, you want to add, let me say, 20 more. We can support that resource modification to some extent. So we can modify, we can add or delete more nodes, more VMs from your current slice. So we're about to add the topology modification. Basically, you can add and delete the links from your request. So that's that's a work in progress now. Yeah.
Okay. All right. So are we? Is any more questions?
About Genie security model. So both she and me, we are working on two different Genie projects, but more on the resource allocation side. So there's a whole Genie trust and security framework. We both, I'm speaking of she too, but we probably are not the best person to talk about Genie security model. So I guess you need to talk to the other people. We can point you to the right person to talk about the framework. There's always a distinguish between the framework and the implementation. So, yeah, okay.
Great. Okay, so I think we are out of time now, so I'd just like to thank all the speakers and a very attentive audience with some very good questions, which is great. So briefly, just what's going to come out of these requirement discussion is that we'll put together a few people to take on a piece of work to document the basic requirements that fed into the NSI framework and the connection service model, and so that we've got a document we can point to say these are the basic requirements of that service. So that's pretty much a wrap for today. I just remind you that there will be, in the glyph section, there will be some NSI related meetings. There's So the projector's not working, but there'll be an update on status of NSI version 2 on Wednesday at 1:45, and then at 2:30 there'll be an auto-goal task force meeting. And then on Thursday there's a couple of sessions on NSI implementation, which will be led by John. So thank you all for your attention, and enjoy your lunch.